Representing real numbers on the number line. For this, let us take a question. Visualize the representation of 5.3 reckoning over 7 on the number line up to 3 decimal places, that is up to 5.377. For this, let us take the number between which this number lies, that is 5 and 6. Here one decimal place is written. Now let us take two decimal places. So we write 5.30 from here, and we increase this by 1, then we get this, that is 5.40. And now this number lies between these two numbers. Now we take three decimal places, then we get 5.370. Now increase second place by 1, then we get 5.380. Now this number lies between these two numbers. We plot 5.3, we plot 5 and 6 and mark the parts between them in 10 equal parts. This is 5.1, this is 5.2, this is 5.3, 5.4, 5.5, and so on. This is 6.0. Now we have seen that 5.37 lies between 5.3 and 5.4. So we again draw a number line and we plot 5.3 and 5.4 and divide this part into 10 equal parts. This is 5.31, this is 5.32, and so on. This is 5.37, this is 5.38. We mark 5.37 and 5.38 on the number line. Now we take these two parts on the number line. This is here 5.37. Now we put 0 after non-zero number in decimal. So this is 5.371, 5.372, 5.373, 5.374, 5.375, 5.376. This is 5.377, which is to be represented. Let us take another example. Visualize the representation of 2.3 recurring on 3 on the number line up to 4 decimal places, that is up to 2.3333. For this, firstly we take one decimal place, then we put this number between 2.0 and 3.0. Now we take two decimal place, that is if we write 2.3, then we can put 0 after 3, and now increase 3 by 1, then we get 2.4, and now this number lie between this. Again we write two decimal places, that is 2.33. Now increase second decimal, so we get 2.34. 0 is put in after is put 0 is put after non-zero number in decimal, so this number lies between these two numbers. Now we take three decimal places, so we get 2.333. Now increase the third place by 1, so we get 2.3340. Now this number lies between these two numbers. Let us show this number on the number line. We draw a number line and show 2.0 and 3.0. This lie between, and we divide this number, this part, into 10 equal parts. So this is 2.1, this is 2.2, this is 2.3, this is 2.4, this is 2.5, and so on. This is 3.0. Now we have to put 2.30 and 2.40. So we take 2.30 here 2.40, and divide this part into 10 equal parts. This is 2.31, this is 2.32, this is 2.33, this is 2.34. Now we have to put 2.330 and 2.340 on the number line. Then we draw this number line and we take 2.330 here, 2.340 here, and divide this part into 10 equal parts. This is 2.331, this is 2.332, this is 2.333, this is 2.334, and so on. This is 2.340. Then we have to plot 2.3330 and 2.3340. Then we write here 2.330 and we make 10 equal parts, then we get here 2.3340. Now this is 2.3331, this is 2.3332, this is 2.3333, and so on. Then we get here 2.3340. Let us take a question to represent root x on the number line where x is a positive real number. For this, what have we to do? For this, we draw AB is equal to x. Then we proceed it by 1. So AC is x plus 1. Now we draw perpendicular bisector of AC. Then O becomes the midpoint of AC, and AO is equal to CO, and CO is AC by 2. That is x plus 1 by 2. Now we draw DB perpendicular to AC. Join OD. Then OD is equal to OC, because OD and OC are radii of the same semicircle. OD and OC are equal. So OD is x plus 1 by, OD is x plus 1 by 2. OB can be found. OC is x plus 1 by 2. BC is 1. So we subtract BC from OC to get OB. So OB is equal to OC minus BC, which is equal to x plus 1 by 2 minus 1. This equals x plus 1 by minus 2 by 2. This is 1 minus 2 is minus 1. So this becomes x minus 1 by 2. Now in right triangle OBD, we know OD and OB. OD is x plus 1 by 2. OB is x minus 1 by 2. On applying Pythagoras theorem, we can write BD square plus BO square is equal to OD square. From here, we can write BD square is equal to OD square minus BO square, which is equal to OD plus BO, OD minus BO. This is A square minus B square, which is A plus B into A minus B. Now putting the value of OD and BO. So this expression obtained. Now 2 is here, and we add above numbers. So x plus 1 plus x minus 1. Here 2 is here. X plus 1 minus x minus into x minus x minus into minus plus. Now 1 is cancelled out. X plus x 2x. Here x is cancelled out. 1 plus 1 is 2. 2x by 2. 2 is cancelled out. 2 is cancelled out with 2. So BD square is equal to x. Therefore BD, on taking a square root on both sides, here we obtained BD, here we obtained root x. So BD is root x. Therefore BD is equal to root x. Now take x is root 3.5. Represent a square root of 3.5 on the number line geometrically. What have we to do? We draw a number line, take a point A, and draw AB is equal to 3.5. And BC is equal to 1. So AC is 4.5 centimeter, and AC is bisected perpendicularly to get O. O is the midpoint of AC. Now put pointer at O and pencil at C. Draw a semicircle. Now on B, draw perpendicular using protractor. That is, make angle ABD 90 degree using protractor. Then we get BD, and BD will be a square root of 3.5. This is 3.5. Now putting pointer at B and pencil at D, draw BD on B. This is B. BD becomes BD because they are radii of the same arc. So B is equal to a square root of 3.5. Here steps are written. Now let us take operations on rationals and irrationals. The sum or difference of a rational and an irrational is irrational. For example, 2 plus root 3. It is an irrational number. Or we take root 5 minus 2. It is also an irrational, because if we put irrational number in a decimal form, the difference or sum becomes non-terminating, non-repeating. The product or quotient of a non-zero rational and an irrational is irrational. For example, 2 into root 5. 2 root 5 is an irrational. Here non-zero rational is written because if we take 0 and multiply with any irrational number, we get a rational number. So the product of a non-zero rational should be done with an irrational number, then we get an irrational number. If we divide root 5 with 2, then we get an irrational number, because root 5 has decimal as non-terminating, non-repeating, and dividing this with 2 we get a non-terminating, non-repeating decimal. So the product or quotient of a non-zero rational and an irrational is irrational. If we add, subtract, multiply, or divide two irrationals, the result may be rational or irrational. Let us see an example for this. Here, you may verify these properties using some your own examples. Now let us take this addition: 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. Here these two numbers are irrational. If we add these two, then 2 root 2 plus root 2. Before root 2, 1 is hidden. So on taking root 2 common, then we get 2 plus 1 here. Then on taking root 3 common, we get 5 minus 3. So 3 root 2 plus 2 root 3. Here sum of 2 irrational is irrational. But if you add root 3 with minus root 3, if we add root 3 with minus root 3, these two numbers are irrational, but their sum is rational, which is 0. Now let us take this example. Here 6 root 5 is irrational, 2 root 5 is irrational, but their product is rational, because we can write the product as 6 into 2 into a square root of 5 into 5. That is 6 into 12 into 5. Here 2 5 occurs, so we can take 1 5 and it gets 60. 60 is rational. Divide 8 root 15 by 2 root 3. 8 is divided by 2, we get 4, and root 15 by root 3 can be written as square root of 15 by 3, we get 5, so we get 4 root 5. Here these two numbers are irrational, but we get the quotient as irrational. Radical sign. What is radical sign? Let a be a positive real number and n be a natural number. Then nth root of a is b if and only if b to the power n is a and b is positive. The symbol, this symbol is called radical sign. Some rules regarding to radical sign. A square root of ab is a square root of a into a square root of b. A square root of a by b is a square root of a by a square root of b. A square root of a plus a square root of b into a square root of a minus a square root of b. Here this is x, this is y. X plus y into x minus y. X square means a square of root a, that is a, minus y square means a square of a square root b, that is b. So the product becomes a minus b. Here a plus root b into a minus root b, this is x plus y, this is x minus y. Then x square minus y square, the square of x, that is a square, the square of y, that is a square of root b, which is b. Root a plus root b into root c plus root d. Now we multiply root a with root c, we get a square root of ac. We multiply root a with root d, we get a square root of ad. We multiply root b with root c, we get a square root of root bc. We multiply root b with root d, we get a square root of root bd. Now a square of a square root of a plus a square root of b. Then this is x, this is y. X plus y whole square, x square root a square is a, plus 2ab, 2 into a square root of a into a square root of b can be written as 2 into a square root of a b. A square root of b, a squared is b. Now simplify the following expressions. 5 plus root 7 into 2 plus root 5, 5 plus root 6 into 5 minus root 6, a square of root 3 plus root 5 whole square, a square root of 11 minus square root 7 into a square root of 11 plus a square root of 7. First, 5 plus root 7 into 2 plus root 5. 5 into 2, 10. 5 into root 5 is 5 root 5. Root 7 into 2 is 2 root 7. Root 7 into root 5, that is root 7 into 5. This can be written as this. Now, we cannot write further any step. This is the last step. Next, here a plus b into a minus b becomes a square minus b square. A square root of 6 squared is 6. 25 minus 6 is 19. Here this is a, this is b. A plus b whole square, a square plus 2ab plus b square. Square root of 3 square is 3. 2 into a square root of 3 into 5 is root 15. A square root of 5 square is 5. 3 plus 5 is 8. We get 8 plus 2 root 15. A square root of 11 plus a square root of 7. This is a plus b, this is a minus b. Then a square minus b square. This square is 11, this square is 7. So 11 minus 7 is 4. Now, to rationalize the denominator, that is, to make the denominator rational, rationalize the denominator of first 1 by root 2, second 1 by 2 plus root 3, 5 by root 3 minus root 5, 1 by 7 plus 3 root 2. We have to make this irrational number rational. Here 1 by root 2. To make root 2 rational, we multiply it with root 2 because root 2 into root 2 is 2. So if we multiply denominator with root 2, then we have to multiply numerator with root 2 also. So it becomes the product above becomes root 2, the product below becomes 2. Here we get a number whose denominator is rational. This is required. Here this is irrational number. Now multiply numerator and denominator both with changing this sign. This becomes minus, then we multiply 2 minus root 3. Why so? Because if we multiply the two numbers, 2 square minus root 3 square occurs and 4 minus 3, it gives denominator 1 which is rational. Here denominator 1 is hidden. Next, 5 by root 3 minus root 5, we take its rationalizing factor after changing this sign, then we change it as plus and multiply numerator and denominator with root 3 plus root 5, then we get 5 into root 3 plus root 5. Here root 3 square is 3, root 5 square is 5, 3 minus 5 is minus 2, so we write minus 5 by 2 into root 3 plus root 5. One by 7 plus 3 root 2. Here we have to multiply after changing this sign the denominator and numerator. So we multiply the numerator and denominator with 7 minus 3 root 2 and 7 minus 3 root 2. Then this gives 7 minus 3 root 2, and here a square minus b square. 7 square is 49, 3 root 2 square. 3 square is 9 and root 2 square is 2. So we get 18 here. And lastly we get 7 minus 3 root 2 by 49 minus 18 is 31. Note, to make the denominator rational, if it is in the form of square root of a, then we take rationalizing factor at root a. We multiply numerator and denominator with root a. If it is in the form a plus minus root b, then rationalizing factor is, if here plus, then here in rationalizing factor we write minus. If denominator has minus here, then its rationalizing factor has plus here, means the irrational the sign of irrational part gets changed. Here plus, then here minus, here minus, then here plus. If it is in the form, if it is in the form a square root of a plus minus a square root of b, then the rationalizing factor is a square root of a. Here plus, then here minus, then here plus, means the sign of irrational part will be changed oppositely. That's all for today. Thank you.